This video is going to cover long division and synthetic division for dividing by a binomial. Now, we didn't really cover dividing by a monomial because it's pretty easy, but we're not really going to worry about that. We're going to look at dividing by binomial first, then we're going to look at long division and synthetic division when you can't factor what you've got, which we're going to primarily focus on long division and synthetic division. So this example I'm going to work is really just going to be so you can see it, but it's going to be pretty easy to understand. So anytime you're dividing something like a trinomial by a binomial, sometimes you can factor out that top part, which we could use the product sum and factor that out, and it would be, let's see, x minus 2 or w minus 2 and w minus 5, and it would be over w minus 5. Now that's going to allow us to cancel out w minus 5 and w minus 5, and we'll be left with w minus 2. So those are the pretty easy, simple, straightforward ones, and you'll probably only have like one of these on your homework. We're not going to focus too much on that. We're going to look at long division and synthetic division when factoring is not possible. So I'm going to pretty much give you the choice to whichever one you want to use. Personally, I like synthetic division better, but I'm going to show you both so that you can use both. If you notice on 5 and 6, we have the same exact problem. So when we do this, we'll end up getting the same answer, but it's a good way to show you that either way you do it works. So first of all, let's look at number 5, which is long division. So if we want to divide x squared plus 3x minus 48 by x plus 8, we are going to first look at doing this by long division. Which long division means we're going to write this out, which you may have not have done this in a very long time, but we write out what we're dividing by outside of almost a square. Kind of looks similar to a square root sign. It just doesn't have like this top part or this part here. Instead, it's just kind of a curve and then a line. But I'm not really, if you just do it like this, I'm not going to be mad about it. All right, so we're dividing x plus 8 by x squared plus 3x minus 43. All right, this is going to be a little bit tricky, so just be sure to pay attention to these steps. So pretty much what we're going to do when we divide this is we're only going to look at this x to figure out what's going to go on top here, because that's where we put what we're dividing by or what we're like how our long division is going. That's where we keep up with everything, is this top row, if you don't remember. All right. So when we're looking at that x, we're comparing it with this first term, which is x squared. And you need to ask yourself, how do I get from x to x squared? What can I do to x squared to make, or what can I do to x to make x squared? And that is multiply by x. So essentially you're thinking, what can I multiply by x to get x squared, or that first term? And you're going to place that over this second term. Because here's what you're going to end up doing with that. Essentially, you're saying x times x plus 8, and you're going to distribute that, which will give you x squared plus 8x. And you're going to write that below your first two terms that you're dividing by, and you're going to subtract that. So you're subtracting everything. That's what allows you, if you remember when you're young and say we've got, I don't know, 500 and we're dividing it by long division by 5. The first thing you do is look at these two numbers here, and you want to say, okay, how many times can we divide 5 into 50? And it would be 10. Or I guess you would write it like this. It would be 10. And then we say, okay, so 5 times 10 is 50. We subtract those, so we're good. And then we say, okay, how can we get from 5 to the rest of this, which would just be 0, and that would be 0. So then our answer would be 100. We wouldn't have a remainder. It's the same type of process. It's just a little bit more complex. All right, so the second part of this is going to be to actually do this subtraction. So we're saying x squared minus x squared, so that's going to be 0. So that's going to be gone. Now we're saying 3x minus 8x. So that'll be negative 5x. So we're done with that. Now we're going to bring down our minus 43. And we're going to go through this process again, but we're only going to look at x. So we're going to say, okay, how can we get from x to negative 5x? By multiplying. And that's going to be to multiply by negative 5. All right. So now that we have done that, we're going to come back and essentially say negative 5 times this entire x plus 8. And that's going to give us negative 5x minus 40. So that's what we write below this negative 5x minus 43. And we're subtracting that as well. So now the last step is going to be this actual subtraction. So we're taking negative 5x minus negative 5, which will be plus 5. So that's going to give us 0 there. And now we're saying negative 43 minus a negative 40, which would actually be plus. So we end up with negative 3. That is our remainder. And here's how we write that. Okay, so what you divided by at the top is part of your answer. That comes out just like you see it, x minus 5. Now, this remainder is going to go over what you divided by, which was x plus 8. So we're going to write the rest of our answer as minus 3 over x plus 8, because this was a minus 3 here. And that is your final answer. So when you have a remainder, you have to put it over what you divided by almost as a fraction, or it's almost like a fraction. So your answer for number 1, after you do long division, is x minus 5 minus 3 over x plus 8. And be sure to get all this written down real quick. Pause the video and get this written down because I'm about to erase it. All right, so now we're going to look at synthetic, which I think this is easier. It's pretty. It's just a lot easier to me than long division. All right, so if you want to solve this by synthetic division, here's what you're going to do. The first thing you're going to do is take this x plus 8, and we are going to set that equal to 0 and solve for it, which is just going to give us x is equal to negative 8. Now that's important. We're going to stick that over here, and that's going to be important, and you'll see why, because that's what we're going to use for our synthetic division. Now you're going to create an L, which is going to end up being like a table, and you'll see once I fill everything in. Take all your coefficients for what you're dividing and put those, almost like we did our matrix stuff, rewrite those in one row. So we'll have the coefficient for x squared is 1, coefficient for 3x is 3, and 43 is just minus 43. All right, so the process of doing this is going to be some adding and multiplication. So I'm going to show you how it looks. And it's really, once you get the pattern of this down, synthetic division is so much easier than long division. So your first number that you have in your table, you're going to bring that down. And I always draw this arrow to remind me of that. You're going to bring that down, and it's going to be 1 below this bottom line you've got here. Anytime you have something below that bottom line, it's going to be part of your answer. Now, we're going to put something here and here to help us find those answers, and here's how you do it. You're going to take this number that you found or that you brought down below this line, and you're going to multiply it by whatever number you've got outside to the left of your table, which in this case is -8. So we take 1 multiplied by -8, and then we rewrite that here in our second column. So anything inside of this table is always added or subtracted. And then when you bring it out here, it's multiplied by this number, which is -8, and then it goes back into the table until you're pretty much at the end. So we're going to take 3 minus 8, which will give us -5. So -5 is going to be part of our answer, and then we're going to take -5, multiply it by -8. That'll give us 40 back inside of our table. And then to finish this off, we're just going to take -43 plus 40, which will give us -3. Now, this last number here is like our remainder, as we did in the past. So whatever you have as your last number, I always circle it to remind myself it's the remainder. The reason that's important is because your remainder always goes over the first number, or this number that you're dividing by, this binomial that you're dividing by. Now, a big thing here is when you rewrite these two numbers, go back to your original number or trinomial that you were dividing by, or that you were taking and dividing. Whatever the highest exponent is, that exponent was x squared. When we rewrite our answer, it becomes x. So if this were, say this were 2 here, it would be 2x. But since that coefficient is just 1, we just leave it as x. And then -5 comes down without any variable, because as you progress through this from left to right, your exponents will keep going down. So since this was x to the first, this is not x to anything. It's just x to the 0, which is just 1. And then we bring down our remainder over x plus 8. And that is our answer. And if you notice, we got the same exact answer both times. Either way we did it. I personally like synthetic division. Only thing with synthetic division, you've just got to remember to always, when you rewrite your final answer, this exponent of x squared goes down to x. This exponent of x goes down to nothing. And we're going to look at the homework in class, and we'll look at some more complicated problems. No matter what this is, say this were x to the third. That means that this answer would be x squared, and so on. It just keeps progressing down or descending. But once you get the pattern of doing synthetic division, it's so much easier, which we'll look at some examples in class too from the homework. But you're going to be able to take your pick and do whichever one you want. So find which one you're comfortable with and just work with that one.